Muhammad ibn Musa al-Khwarizmi, often referred to as the father of algebra, was a Persian mathematician, astronomer, and geographer born around 780 CE in Khwarizm, present-day Uzbekistan, and who worked in Baghdad's House of Wisdom during the Islamic Golden Age, passing away around 850 CE. His contributions spanned multiple fields and laid foundational principles that influenced global science. Scientific achievements. Algebra. Al-Khwarizmi authored the seminal work Al-Kitab al-Mukhtasar fi Hisab al-Jabr wal-Muqabala, the compendious book on calculation by completion and balancing, which systematized algebra as a distinct discipline. He demonstrated methods for solving linear and quadratic equations, including completing the square with geometric justifications, and introduced concepts like reducing equations to standard forms. Arithmetic and numerals. He popularized the Hindu-Arabic numeral system, including zero, through his book on arithmetic, which facilitated efficient calculations and decimal positional notation, replacing cumbersome Roman numerals. Astronomy. Al-Khwarizmi compiled astronomical tables, Zij, based on Indian, Greek, and Persian sources, refining Ptolemy's models for planetary movements. He also invented the Cine quadrant, an instrument for measuring celestial angles. Geography. His book, Kitab Surat al-Ard, Book of the Description of the Earth, updated Ptolemy's geography with more accurate maps, coordinates for over 2,400 locations, and discussions on the Earth's sphericity, advancing cartography. Other contributions. His systematic problem-solving approaches gave rise to the term algorithm, derived from the Latinization of his name, Al-Khwarizmi, influencing early computing concepts. Impact on European science. Al-Khwarizmi's works were translated into Latin during the 12th century, sparking a mathematical renaissance in medieval Europe and helping to illuminate the so-called Dark Ages. The introduction of algebra enabled advancements in fields like physics, engineering, and commerce, while the adoption of Hindu-Arabic numerals revolutionized accounting and scientific computation, paving the way for figures like Fibonacci. His astronomical and geographical texts influenced European explorers and scholars, contributing to the scientific revolution by providing tools for precise measurement and navigation. Overall, his legacy bridged Eastern and Western knowledge, fostering centuries of progress in mathematics and beyond. Al-Khwarizmi's groundbreaking contributions to mathematics, particularly in algebra, arithmetic, and systematic problem-solving, which gave rise to the concept of algorithms, have profoundly shaped modern technology. The term algorithm itself derives from his name, reflecting his methodical approaches that underpin computational processes today. While not inventing devices himself, his ideas enable the core functionalities of numerous contemporary gadgets and systems. Below, I'll outline key modern devices influenced by his works, focusing on how his innovations in algorithms, the Hindu-Arabic numeral system, including zero and positional notation, and algebra facilitate their operations. Computers and laptops. These are perhaps the most direct descendants of Al-Khwarizmi's legacy. All computer programming relies on algorithms, step-by-step procedures for calculations and decision-making that trace back to his arithmetic and algebraic methods. For instance, solving equations or processing data in software uses principles from his book Al-Jabr wal-Muqabala, which systematized algebra for practical applications like engineering simulations and data analysis. The decimal numeral system he popularized allows for efficient binary and digital computations, forming the backbone of hardware like processors and memory systems. Smartphones and tablets. Mobile devices operate on algorithms for everything from app functionalities to user interfaces and optimization tasks, such as battery management or photo editing. Encryption systems in smartphones, which secure data and communications, build on algorithmic logic for cryptographic processes. Features like voice recognition and predictive text draw from algebraic manipulations and pattern-solving techniques he pioneered, integrated into operating systems like iOS and Android. AI-powered devices, e.g., smart assistants like Amazon Echo or Google Home. Artificial intelligence relies heavily on algorithms for machine learning, data processing, and decision-making. Core ideas stemming from al-Khwarizmi's systematic approaches to problem-solving and logic. Devices with AI, such as virtual assistants, use these to interpret commands, learn user preferences, and perform tasks like scheduling or smart home control. His decimal system supports the massive numerical computations in AI training models, enabling devices to handle complex datasets efficiently. GPS navigation systems and mapping devices. Al-Khwarizmi's astronomical tables and geographical works, which improved mapping and coordinate systems, indirectly influence modern GPS technology. Devices like car navigation units or smartphone GPS apps use algorithms to calculate routes, distances, and positions, building on his refinements to Ptolemaic geography and celestial calculations. Satellite-based systems incorporate algebraic equations for triangulation and error correction, echoing his methods for solving quadratic problems geometrically. Calculators and scientific instruments. Electronic calculators directly embody his arithmetic algorithms and algebraic solutions, allowing quick resolution of equations that he first systematized. Advanced scientific calculators or software in devices like digital multimeters use completing the square techniques for quadratic equations in fields like physics and engineering. His influence extends to instruments like digital astrolabes or sundial apps, though these are niche, drawing from his writings on mechanical timekeeping devices. In essence, al-Khwarizmi's emphasis on logical step-by-step processes and numerical efficiency has made him a foundational figure in the digital age, where virtually every programmable device owes something to his innovations. Without his work, the computational power driving today's gadgets, from everyday smartphones to sophisticated AI, would not exist in its current form.